Hello, hello, this is Brian from Tavarin Games here with episode 3 of our strategy map generator tutorial. Now, last time the episode was getting a bit long, so I didn't get to the point where I was explaining how to do this map wrapping, where you actually just have the map just scroll infinitely in any direction, and you keep getting the repeat pattern. So that way you can have units go off one side of the map, and it's like it's a cylinder. So we're going to go over that today. Now, when I was working on this and trying to figure out how to do it, I looked up online what other people were doing, and there's different solutions to this. So one of them would be to generate the map and then create a copy of the other side of the map on each side, and then anything that goes into that copy gets basically teleported to the other side, and when the camera gets there, it also moves to the other side. But that's a little tricky because you have to make sure those copy tiles are displaying the same unit as the one on the other side of the map, so that it looks seamless when the camera teleports over. So you need, for each of these tiles, you need to be tracking another tile and modifying it. And I thought that would be kind of tricky. So my solution was to just actually move the tile itself. So if we look and actually find where we've scrolled to, you can see these big old green collider boxes that are attached to the camera. And all we're going to do is when we move the camera and any of these tiles end up in those boxes, or in one of those boxes, they get moved to the other side of the map. So pretty simple. And then for anything that's on the tiles, like this, scout I've made in this version, any units, any buildings, any changes you've made, you just make them a child of the actual hex. If you look, we have all the things that are attached to it as children. And then when the hex gets teleported, everything under it gets teleported too. So let's go about that. But the first thing I want to cover, though, is I just figured out a little bit of a glitch in the camera controller script we wrote in the last tutorial. So if you remember, when we're zooming, we made it so that the camera moves to try and keep the mouse hovering over the same tile throughout the whole zoom movement. But one glitch, if we move the camera with the arrow keys and then zoom in and out, we teleport back to that tile. And that's a little funky, and that's definitely going to be a problem when we're wrapping tiles around. If the person's moved really far out, the tiles aren't even there, and we zoom in and out, it's not going to look right. So we need to quickly fix that. Let's explain the glitch first. Let's go over to our camera control script. I've added in some comments for you guys. But the reason we're getting that glitch is we are only updating the camera's desired position when we move the mouse, when the input mouse position has changed. Now, the reason we're doing that is if we just every frame change the desired position, it's just going to match the mouse movement when we're zooming, and we're not actually going to be moving to the right point. And you end up sometimes getting some really funky camera movement when we do this calculation and then apply it to our new position. So we don't want to actually be checking this every frame. We only want to be checking this if the player's moved the mouse, or now in this case, if the player has scrolled using the arrow keys. So we can go down to where the arrow keys are triggered, and we can just take that old mouse variable that's keeping track of where the mouse movement was, and we can just set that to a new vector 3, and we're going to make just that a position that the mouse will never be. So -1, -1, -1, that will never be matched by our input mouse position. Easy to type. So let's save that. Let's go back into the tutorial version, let it compile, run it. And, okay, let's zoom out. Let's put our mouse over this tile, zoom in, zoom out. That looks good. Let's move it, and then with the arrow key, and zoom in and out, and perfect. Move the mouse, zoom in and out, that's fine. Arrow key, and we end up moving correctly. Move with the mouse movement. Look at that. We're always zooming where we're wanting to. There we go. So that has fixed that glitch. If you followed the previous tutorial for the camera movement, be sure to make that quick change, just that one line, in this horizontal and vertical movement where you set the old mouse position to something off camera. Okay, so let's get to the wrapping. So as you saw, again, if we look at my previous game, we need these two big box colliders next or around the camera. So let's make those right now. So turn this off. So the main camera, we're going to create a empty object for the left one first. So barrier left. We're going to add a box collider to it. So we're going to set its size to be really big, bigger than we need. The bigger your map, the bigger you can make it. Now, of course, this is the wrong spot. Right in the middle, well, it's going to try to move the tile off, and you'll never see the tile. So we need to move it off to the side. So let's just set this off to the side. And then we are going to actually change its layer. We're just going to put on a layer we're not going to use. I'm going to use the transparent effects layer. I tend not to use that. You can create a new layer for the barriers, just that will something that's not going to interact with any of your other systems. Because when we're doing the oh, we didn't have the name change. When we're doing the map making, we're looking at the default layer for the tiles there. You're going to want to do that for when we get units and clicking. So this will make sure you never accidentally have the barrier interacted with by any of the systems. Now let's just quickly copy the barrier, paste it, and we're going to make this the right barrier. Again, it's on the transparent effects layer. And we're just going to make this offset positive. So if you look at the camera, we now have a nice big old barrier on either side. Again, you can make them bigger. You just have to get the offset in the right position. Now, when we generate the map, we're going to want to make sure the camera is positioned in the middle so the map is generating between these barriers. So let's do that really quick. We're going to go to our tutorial. Let's go to the map maker. And where we set the height of the camera, before that, let's just move the camera over. Now again, this script is attached to the camera already, so we can just set the position in it. So we're going to want a vector 3. Again, we need to track our Z position. So we want a map size.x divided by 2 will be the middle of our generate area. And then we have map size.y times the 0.86, because again, the hex tiles are narrower, or vertically they pack narrower than 1. So compensate that. And then the minus 10 for our default Z position. So let's save that. Let's go back in. Let's quickly generate a map by turning this on. All right, and look at that. So the map's in the center. Let's move. So again, we're not wrapping the map yet. Hit generate though, and our camera moves it back to the center, vertically and horizontally, where it's supposed to be. So there we go. We have the map in the right spot, so we can now play with those barriers. So one thing though to notice is that the default barrier positions are of course in the wrong spots. So we want these barriers to be right at the edge of where these tiles would be. So as soon as we move the map a bit, those tiles end up overlapping and we can move it to the other side. And we just want a little bit of a gap so that we don't accidentally move a tile back and forth and back and forth and back and forth, because that would mess things up. If we teleport one into the other side on the other barrier, it's then going to want to move back, and that'll just, yeah, it won't work. So let's position the barriers. So in order to do that, we need to actually get the barriers. So we're going to set the barriers in the camera control as public box colliders here. So we need these objects here. So public box collider 2D. And so we're going to go barrier left. And then we want one for the right-hand side. So the barrier right. So we're going to just declare them as box colliders because the only information we need from them is their collider. So those are public. We're going to save that. We're going to set them in a second, but we can first go over to the map maker. Now we're already getting a cam control component once, but we're going to need to now do the barriers, and we're going to need to be setting in the map width as well and syncing that up with what this says so that we can correctly move the tiles. So we're going to make a new variable just to simplify this. So the camera control, and we're just going to call it cam. And then we can set before we generate, we can grab cam and then equal to get component cam control, do that. And then down here, we can just get rid of this. Set that to cam. Okay, and now we can set everything else. So we can send the width over because we are going to need that. So the map size.x, of course, and we don't need to multiply it. It is an integer, so let's cast that as an integer. And now we can do the barrier left. So cam.barrier left, and we're going to do the positioning. So the way we do that, if we look, a barrier is if we look at the box collider, it is the offset. So that's what we're going to change. So let's go here and offset, and that's part of the box collider 2D we set this as, and we're going to need a vector 2. It does not have a Z offset because it's a box collider 2D. And we're going to need the map width, so map size, if I can type right, .x. We are going to divide that by 2, and then we're going to subtract the width of it, and we're going to add 1 to that for this one. So we made the width 100, so that's going to be 51. Now, because this is the left-hand side, we need to make this negative. And then we just set the y as 0. We don't need it to be anything. It in the center of the camera is fine. So that's going to be our left barrier. So let's copy that down and make this our right barrier. Right. Now again, this doesn't need to be negative. We probably should have copied it before we did that. We're going to add that. Now, when we're generating the tiles, we're generating starting from the x0 position, and we're not changing that. So the first tile actually overlaps 0.5 with the left, but on the right-hand side is going to end up right at the number. So if we want a nice small gap, we're going to set this to 50.5f. So this way, we are 1/2 tile away from the leftmost tile on the left-hand side, and 1/2 tile away from the rightmost tile on the right-hand side with our barrier. At least that's what we intend. So let's go back into here. Let this compile. So in the main camera, we now need to set the barriers. So we'll drag these in. So the left barrier and the right one. We're going to save that, and let's run it. So this should generate a map. Well, let's look at the scene, and look at that. So our box colliders are perfectly just 1/2 tile away on the left-hand side and 1/2 tile away on the right-hand side. So the tiles, as soon as we move, are going to overlap nicely, but because we have this 1 tile gap, when they're moved back, they're not going to overlap with the other side. Okie dokie, so that is set. Now, we have to actually move the tiles. We need to jump them from one side to the other. So we're going to create a new function in our tutorial script. Okay, so underneath our, we're in the map maker, sorry, let's go to the camera controller. So after our update where we're doing all this movement, we're just going to make a new void, and we're just going to call this move tiles. Pretty explanatory. So the thing we're going to be using for this is called a overlap collider, and it took me a little while to figure out how to use these. So the first thing we need for an overlap collider is we need a target array to send the collision data into. So we need a collider2D array, so we declare that with the square brackets, and we're just going to call it targets. And we're going to set that equal to a new collider2D array with 1,000 entries in it. Room enough for any possible tiles that could be in there. Honestly, you could probably get away with making this quite a bit smaller, but making it 1,000 means we have plenty of room for anything that ends up inside of it. Now, the other thing we're going to need is a contact filter. So this is what is going to tell the overlap collider what layer to look at, basically. Now, in ray tracing, actually, let's look at the map maker where we do some ray tracing. We use a layer mask. But when we're doing an overlap collider, it uses a contact filter. Not sure why Unity does it that way. The contact filter does contain more data than just a layer mask. But it's what it uses, and it took me a little bit to figure out how to do this because the online documentation sucked. Unity, please fix it and make it clearer. But anyway, we need to then set in the filter the layer mask we want to use. So set the layer mask, so you can see here. And let's make that the default layer. So layer mask dot get mask, and we're going to set that to default because that is where all of our tiles are. So as you saw, we can set other things within this filter, but we don't need to in this case. We're fine just setting it to the default mask because it's going to be at the same Z position as our targets and tiles, so we don't have any other issues. So the way that we actually populate this targets array with the data of the overlap is pretty interesting. So we actually declare a new integer. We're going to call this the count, and we're going to grab our left barrier, and we're going to use the overlap collider function. And so you can see in the overlap collider, we need our contact filter 2D, so we have that as our filter, and we need the results, and that's the targets, so that empty array we're going to populate. So overlap collider actually just outputs an integer, but it puts all of our overlap data, all the colliders that are underneath the box collider of this left barrier, into this targets array. So that's how that works. So with one thing, we end up with the count of how many items we actually put inside this array, and then a big array where the first X number of items, whatever this count is, are filled with our new collider data. So we're going to loop through that. And we're going to start with 0. We're going to do n less than count, and then just n plus plus. Here, let's make that look a little cleaner. Okay, so this will go through all the actual colliders we have within the targets array. So we're going to get the position of the tile in that of that target. So targets n.transform.position, as always. So that is the current position of the tile. Now this is the left barrier we're looking at. So we need if we're on the left, if it's the left barrier, that means the tile moved this way, hit the barrier, and we now need it to jump to the other side of the map on the right. So we know that we need to add the map width. So pose.x plus equals width. So, and now let's just set that back to the targets. Dot transform dot position equals position. Okay, so we've done all the ones on the left. We want to do on the right. We're going to copy this. We don't need all of this, but we do need some of it. So let's copy this. We can get rid of the contact filter data, get rid of the declaration for targets, but we clear out the targets, and then we reset the count, and then this will refill this with new targets. We need to set this to the right barrier and its overlap collider. And of course, in this case, their tiles are moving to the right. They hit this collider on the right. They then need to move to the left, so we are going to subtract the width. Now let me just double check over here that we actually set the width. We did indeed. So when we're generating the map, we are setting the correct width over to the camera. So that is the width that the move tiles function is going to use. Now we need to trigger the move tiles function. So we update the position here in the update function, but we don't need to move the tiles every single frame. We don't need to rerun this and use up that memory. So we're actually going to put a new if statement here. We're going to transform, check the transform position. If it's not equal to our new position that we're trying to move to, so we can move our brackets, then we're going to move to the new position, and we're then going to check the move tiles, and that should all work, theoretically. Now, I actually ran into so many issues with this when I first wrote it, and I'm going to talk to you about why that occurs. But let's run it, and you can see what happens. So let's zoom out so we can see it, and we move, and oh, there's nothing there. And then, oh, wait, we lost our tiles. What's going on? Oh, the map is just disappearing. So let's look at the scene view. We have our box sliders, and then, oh, there's our map. And that's really weird. We should only be, like, it should hit this collider, move over to here, and then we can just keep on moving. It doesn't. What's actually happening is because in my editor, I have an extremely high frame rate. So it's going to run hundreds. Sometimes if we go into game mode, it's going to run at 700 frames per second, 800 plus, sometimes up to 1,000. And what's actually happening, I found out, is the tiles, they get moved, but because there's such a tiny gap in time, where only a millisecond has changed, the program hasn't actually fully registered into the memory all of the new positions of the tiles, so it still thinks there's a collider there. And the box collider returns the tile again, X number of times, who knows, enough to shoot it all the way across the map, sometimes really far, and the map falls apart. However, if we actually build the game, so let's do a build and run, it's going to build into a standard build folder since I've built it before. But let's let it build. It should be pretty quick. There we go. So let this pop up, and you can see, you might not be able to see the top corner, but we're now running at my default frame rate. My monitors are 60 FPS with VSync, and look at that. The map scrolls just fine. There's no issues with our scrolling. We can move it left and right. So the program works fine if we're at a reasonable frame rate. Now, I haven't tested this on a high frame rate monitor like 144 frames per second or 200 plus. So if you do have a high frame rate monitor or you intend your game to be played on those monitors, you may have to double check that everything works. But in this case, it's working fine. So figuring out this problem, let's close this. How to solve this in just the editor. Because it works fine when we export the game at a reasonable frame rate. In fact, we can actually, let's turn that overlay off. So let's go back into our code and we're going to do something. So before we introduced we need a new float, move delay. So let's just make it and we're going to set that to 0. So we need this new float for movement delay. And what we're going to do is we're going to go down to the bottom of our update. So we're in the update. We're going to say if the move delay is, we need the if move delay is greater than 0, we're going to subtract from it time.delta time. Delta time. Now down here, after we move the tiles, we can set move delay equal to 0.01 F, so 1/100th of a second. I've tried, you can try smaller values and see if it still works. I found 0.01 works just fine. And now we go up here. When we're moving the tiles, let's actually tab, we're going to introduce a new if statement and only do it if the move delay is less than or equal to 0. We're only going to move the tiles at that point. So this way, this will jump it up, and then it will wait a couple frames for all the new data if you're running at a very high frame rate. And if you're running under this, then the move delay will just be chucked down right away, and you're good to go. So let's go back into the editor. All right, press play. And we can zoom out and start moving, and there we go. Look at that. The map is moving just fine. If we look at the scene, it's moved over. Click the camera, and the barriers are fine. So these tiles are right next to it, and on the next frame, let's just move a tiny bit, and they've moved on over to here, and we have this new next row that's the one lower, or column, I should say. So look at that. Our map is now wrapping around. Again, if you want things to move with the map, all you have to do is make those things a child of the hexagons themselves. And we'll be doing that for the resources and trees and hills and other stuff we add in future tutorials. Now, if your editor runs at a fairly low or standard frame rate, you might not need to put that fix in place. However, with that fix, you can ensure for very high frame rate monitors that it is going to make sure the tiles actually move correctly and you don't have any issues when the frame rate goes too high. But all right, fixing that was what actually saved me working on this and got me to the point where I was adding in all these different resources and developing different types of land and units and pathfinding and all of that. And none of that would have happened if I hadn't figured out that it was the frame rate causing that bug. So yeah, you might not have that bug. It might work just fine for you. But I do recommend adding that little bit of code in, this movement delay, and applying it to our tile movement. Since the map is wide enough, if you make the map wide enough that it goes off the edge of the camera, if we zoom out, even at a high frame rate, the player is not going to see these tiles coming into frame because they're going to move a little bit and they'll already be over here, even if it's over here, and show up on camera. Now, somebody on an ultra wide, you might have to limit their zoom or something to prevent the edge of the map from being seen. But for the most part, this is now working just fine. So I hope you enjoyed that tutorial. That's all we're going to cover in this episode. In the next one, we will start generating the different types of terrain. So mountains, potentially deserts, grassland. We'll see how much we can manage to get added in the next one. So stop by the next episode and let me know if there's any better way for doing this, for moving the tiles around. Again, this is a learning experience for me. I was figuring this out, just trying to make this, and I wanted to show you guys how I solved these problems and how you can potentially do it too. But if you've got a better way, if you've managed to integrate a wrapping around map system in a different way for a strategy type game, please let me know in the comments below. And stay tuned for future episodes as we add in all these new features and we start to make a really cool map maker with unit pathing and all sorts of different resources in that. Have a good one.